Hi, I'm Shen. I will present our work on historical watermark recognition. When looking through an old piece of paper, one can see in transparency complex visual patterns, called watermarks. They come from the historical paper fabrication process. Paper was made in molds where the paper maker would place a small wire to make a mark that identifies production. Historians have created catalogs where they draw tens of thousands of watermarks which allow them to date paper. In this work, we present a large public dataset for watermarks recognition, a new score to compare the deep features of two watermarks, and a weakly supervised method to learn better features for watermark recognition. We start by presenting the dataset we collected to evaluate several important tasks for watermark recognition. The classification dataset contains in total 100 classes with 50 training images and 10 validation images in each class. This dataset can be used to train a standard classification neural network. The one-shot dataset contains another 100 classes, with each class contains one clean watermark as reference and two cloned query photographs. This dataset can be used to evaluate one-shot recognition. The cross-domain dataset has 240 classes. Each class has a clean join as reference. This allows us to evaluate the scenario where one wants to find a join in a catalog corresponding to the photograph, which is of important practical interest. We will now discuss how to compare watermarks images. To tackle the problem, we first train a standard classification network on the classification dataset. One strong baseline of one-shot recognition is to compare the global pooled features, which are extracted from the pre-trained network. The results of standard one-shot recognition are very encouraging, but are poor in the cross-domain setting. Since watermarks are closely aligned, we tried to keep the spatial information by comparing intermediate features at the same position. The performance are largely improved on all the three datasets, particularly on the cross-domain setting. As pairs are not exactly aligned, we considered allowing matching with the local features at other positions. Each local feature from the source image is matched densely in the target image, and only its best match is kept. We define a local matching score which considers for each local feature its similarity with its best match and the consistency of their spatial location. With using our score, the accuracy can be largely improved on all the three datasets. Note that we also compare to other few-shot methods which can be found in our paper. To further improve the performance on the cross-domain setting, we propose a weakly supervised feature fine-tuning strategy. Our idea is to form some positive and negative pairs, then train the following triplet loss. The goal of the triplet loss is to push the positive pair have larger similarity while reduce the similarity between the negative pair. Here, f theta is a feature extractor with parameter theta, which is the network pre-trained on the classification dataset. So the next question is how to get the training data. For a given feature, to find its negative samples, we simply take its top matched features from different classes. While for the positive samples, we search among high-ranked features and make sure that they belong to the same class, then check they also have small spatial difference. In terms of the results, fine-tuning features significantly improves the performance. Note that our approach also outperforms other domain adaptation methods, and we also achieve state-of-the-art on sketch-based image retrieval datasets. All these details can be found in the paper. Here is a qualitative example of the results given by our approach. We can see the task is challenging since the grand choose class has many distractors with minor differences and the matched pair has a clear domain gap. To summarize, we propose a dataset and a consistency-based approach for historical watermark recognition, the dataset, our implementation, and more visual results can be found in the project page. We will also develop and put in service a web application based on the proposed algorithm. Thank you for your attention.